Let us talk about node. Node is a special data structure that is only used for linked lists. Now, again, before we start talking about linked lists as a data structure, we need to recognize this concept of node as a placeholder for any data type and also to create links, or as many people says, connections. Node consists to have a data and a next. Data is the value that you're gonna hold in this node. That's why we need to provide its data type. Let us start with a string just for the purposes of illustration of this node. Next, it's a node. I know what you're thinking. We're creating a node. How come we're gonna have a node as a .next? When we develop this data structure, it's important to recognize that we're gonna store a value or a data inside of the box node. That next will be the value that connects a node to another node. Now, you might have seen that instead of data, some authors they have different names like value, element, or key. Or you have seen instead of next the value of link. It doesn't really matter as long as you're consistent how you access that information. So node has two fields, data, which is the value that you're gonna hold in this particular box, and next, which represents the connection to the next value. It doesn't hurt to have constructors that will initialize these fields. You can also have a constructor that only takes the value data as a parameter. We can take advantage of the constructor that we already defined on line 5 in order to invoke it in this class. We can use method overload that will provide the values of data, and the .next, since it has been only been defined as the data, will pass null for the next. Let's pay attention what is happening on line 10. Line 10 uses the keyword this to refer to a constructor that belongs in this class. We already know that. That's on line 5. Line 5, it takes two parameters, a string and a node, and it will initialize the fields in this class, the ones that you can see on line 2 and 3. Now what's happening on line 10 is that we'll call the method defined on line 5. It will pass data and the value of null. Since the purpose of the constructors is to initialize all the fields, we must initialize the next, even if that this constructor doesn't have it as a parameter. We'll provide the value of null to initialize next. Next is a node, as you can see on line 3. Null is the default value for all the objects in Java. In theory, this is the only thing you need to know about node. Let's test it. Let's do the tester for node. We would like to create a connectivity this way. B connected to A, connected to C, connected to E, connected to D. Now remember that in nodes, we don't have values like that. We have to create a node object with a corresponding value inside of the data structure node. Therefore, we need to create 5 instances of node. Let's do this. What we did right now is that we create 5 instances of nodes, n1 through n5, with a corresponding parameter a through e. Notice that we're using the second constructor that we define in node. This constructor takes only one parameter, data. The next thing we have to do is to establish the connectivity between nodes. Let's start with the node containing B, which is indeed N2. The way we connect N2 with another node is through the .next. Therefore, N2.next is connected to the node containing the value A, which is indeed N1. N1.next is connected to the node containing the value C, which is N3. N3.next is connected to the next node containing the value E, which is N5. And N5 is connected to the node containing the value D, which is N4. N4.next, it's indeed null because that's the last element in the connection. The question is, do we need line 14? In theory, it's important to claim that. But if you remember, since we're using the constructor number 2 in the class node, we internally call the constructor on line 5. And we're actually initializing the .next through null. Therefore, we don't need it because it's already been initialized to null. Suppose we want to print the value n2, which is the start of the connection. I know what you're thinking. Maybe this is a good time to present the entire connectivity. Let's save, compile, and run this program. Look what we got. This is the hexadecimal address location of the class node. We were expecting the entire connectivity, very similar for what we got here in the first place. However, this breaks our heart because nothing of that gets printed. Why? And two, it's an object node. Since we don't have a representation for this, the toString, then we're printing the hexadecimal address location where the object node n2 is located. So in case you want to print the actual value of n2, you have to add here the data that you want to access. Now let's go back and save and compile this program, and let's see how this changed our code. Now we have B. So B is fine. The only problem here is that it's only printing the only value in this node, which is B. How about if we want to print the rest or the remaining connectivity? We can do the following. We can do n2.next. But now remember what happens when we do this. It will print the hexadecimal address location of the next node, which is n1, the node containing the value 8. Let's save, compile, and run this program. There it is. So how can we get the value? Well, let's go back to the code. n2.next will point to the node containing the value 8, but it's not accessing the data. We need to specify that is the data that we want. Wait a minute. That means that in order to print the entire connection, do we need to do .next, .next, .data in order to get the third value? n2.next, .next, .next, .data in order to get the fourth value, and n2.next, .next, 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 .data in order to get the fifth value? Let's save, compile, and run this program. Well, indeed, we got all the values. However, if we go back to the code, that's not cool, because that means that we have all this pyramid of printing. It's a little bit too much. I mean, with 5 nodes, it's okay. But what happens when you have 5,000 nodes? Are you going to establish that connection? Probably not. Therefore, we need to find a way to access that information systematically. As you can see right now, what we're doing right now is only repetition. You know, every time you see a repetition, that is a job for loops. How can we make this program a little bit more systematically effective? Well, remember that loops there's repetition, and we have here the system out print line, which is the repetition. What we need to do is to need to check as long as something will remain true, we're gonna do this printing. This is very important. Now notice that we are started at n2. Might as well call this guy n, which is a node that points to the same address where n2 is located. This line, ladies and gentlemen, is important to keep a copy of the value in order to not touch the actual first element of the node. This will make sense in the next videos when we talk about linked lists. Now, we're gonna stop. We need a stopping criteria. And as long as we don't hit the null, because remember that's the last value, then we're gonna print the value n, that data. The only remaining thing that we need to do as part of the 4 elements of a loop is the update. Notice how n2 is always being updated by the .next. Therefore, what we need to do here is to move n by using the n.next. This value will allow us to move forward through the next connectivity to the next value. Let's save, compile, and run this program. There you go. We can print them all together. You can make it even nicer when you concatenate in the code these values like this. And instead of print line, just print without the line. At the end, it will not hurt just to go to the next line, so you make it more clear. Let's save, compile, and run this program. It looks more nice. Very similar as what we were expecting. It's not perfect, but it helps a little bit to understanding the navigation of these nodes.